Parallelogram of forces. The forces acting at a point that are in equilibrium, the forces are represented in the sides of polygon. F1, F2, F3, F4, F5 can be represented in a polygon parallelogram as F1, F2, F3, F4, F5. Example 5. The two forces of 20 Newton and 40 Newton act at a point and the angle between them is 30 degrees. Find the resultant force. Solution. By trigonometry for triangle, we have resultant rho squared equal to p squared plus q squared plus 2pq cos 30 degrees. Substituting the values, we have that rho squared is equal to 40 squared plus 20 squared plus 2 in bracket 40 times 20 cos 30, making rho the subject of the first formula. The square root will now cross over to become square root of in bracket 40 squared plus 20 squared plus 2 in bracket 40 times 20 cos 30, close bracket. Therefore r is now equal to square root of 3385.6, which is 58. Therefore resultant force is equal to 58 Newton. Direction of the resultant force is obtained using sine rule. 20 over sine B equals to 58 over sine 150. Sine B, by collecting like terms, sine B is equal to 20 sine 150 all over 58, which will give us 0.1724. Getting the sine inverse when sine is crossing over, it becomes sine inverse of 0.1724. We have 9.93 degrees of the reaction. Example 6. Figure 135 example shows a parallelogram having two sides of 10 Newton, having the diagonal at an angle of 60 degrees and the angle of the side of the parallelogram as 120 degrees. Find the resultant F in figure 135 above. Solution. Using cosine rule, F squared, capital F squared is equal to capital Q squared plus capital P squared plus 2QP cos theta, where theta is the angle between the forces P and Q. Theta is equal to 60 degrees, Q is equal to 10 Newton, P equal to 5 Newton, F is unknown. So, substituting the values, we have F squared is equal to 10 squared plus 5 squared plus 2 times 10 times 5 cos 60. F squared is equal to 100 plus 25 plus 100 times 1 over 2. F squared is equal to 100 plus 25 plus 50 is equal to 175. F is equal to the square root of 175, which gives us 13.23 Newton. Direction of F tan alpha equal to in bracket P sin theta all over in bracket Q plus P sin theta, where alpha is equal to direction of force F. Therefore, tan alpha is equal to in bracket 5 sin 60 by substituting the values all over 10 plus 5 sin 60. Alpha is equals to tan inverse of 0.30217. Alpha is now equal to 16.8 degrees. Example 7. If a force P of 40 Newton acts in direction due east and another force Q of 30 Newton acts in the direction due north, calculate the resultant of these two forces. Q at due north 30 Newton, while P at due east 40 Newton. We have to get the resultant R. We have that from Pythagoras theory, the square root of the hypotenuse is equal to the sum of the squares of the other two sides. R squared is equals to P squared plus Q squared. R squared is equals to 40 squared plus 30 squared, which is equals to 2500.